when I stay behind the camera and keep my very handsome face to myself. We had a problem with some of our interdigitated contact pads. We had electrical shorts in our contact pads, and to try and clear the way, and remove the shorts, we used nitric acid because nitric acid is the only acid that will dissolve gold. So I understand. I'm sure there are some other acid, but let's say available in our lab. However, after using nitric acid, we found that we can't have nanorods depositing on our substrate anymore. Too bad. So we did piranha etch, and twice. That didn't exactly solve the problem. Today I got some results that seemed to show that maybe we were getting somewhere with this substrate. Unfortunately, though, some bad things happened to it. I think I accidentally touched it with the tweezers, and that completely destroyed it. So for the results, that's our image with contact pads. You can see I've shown this image before. We try to when we edit this juxtapose this so we can see what the nitric acid did. But I think it did a very good job. You can see, if you look, there's some kind of structures going on here, which are usually not available. See there. I would say there's some DNA what's going on. Let's look at another image which I took today. So that's the problem with the tweezers touching the contact pads. It really completely grazed the thing. Then you can see some nanorods, not very satisfying, not a lot of them, but definitely some. So that's a positive thing, although because of the mishap with the tweezers, this is now completely useless. We can maybe use it to do other experiments, see if we can treat the problem with the tweezers. This image, which I'm showing right here, don't worry about that. I don't know what that is, but whatever that is, definitely no nanorods. Usually what happens is you get more nanorods in these areas with no contact pads in them than on the areas with the metal, the gold. Because we're trying to figure out, we thought at some point, maybe the problem is with the solution. But after this, the samples are made from the same solution within minutes of each other. You can definitely see networks that's densely populated. That's beautiful, right? Well, they're not exactly beautiful as I want them to be, because we want them to have a more straight line kind of thing going on, nicely aligned. But for the sake of showing that we have something, definitely we have something.